Once again, hello everyone. This recording is about my final project of course, ADTA Advanced Data Analytics 550. So, and the name of the course is Deep Learning with Big Data. Let me introduce myself. I am Teja Mandaloju, currently pursuing my master's degree in data science, and I'm in my third semester now. So, and these are the table of contents for the final project. It has project overview, data sets used in the final project, model architecture, that is initial CNN, performance comparison, identifying performance issues, redesign CNN model and its training, accuracy comparison and conclusion, and thank you. So you can see again, these are the table of contents for my project. And this is a project overview. So our goal is to implement, train, and evaluate convolution neural networks using TensorFlow. And the data sets we have used in this project, the entire project, are two kinds of data set. The first one is Intel image classification. Again, this is not used for training. This is a part of the final project, but this is not used for training. And the CIFAR data set, this is used for training purpose. Uh, the constraints we have is no use of Keras, it's only TensorFlow. And also, as part of the final project, it has been divided into some parts. You can see these parts here. Uh, the first part is about using only TensorFlow directly in coding. I know that half of the codes, our course is based on Keras, and the other half is based on TensorFlow. But in the final project, we are allowed to use only TensorFlow and not Keras. That is strictly mentioned in the document which is provided in the Canvas. Um, and the part two is about a data set of images or audio files. So basically, we were asked to search for a data set of images in Google or any site, and then go through the data set, what are the attributes it has, and how it can be utilized. So it's just a normal task. So for this, I have used Intel image classification data set, and then part three is about obtaining CIFAR data set, that is from Canvas, downloading it from Canvas and uploading it into GCP, and then training the model using that data set. So basically building, training, testing CNN on CIFAR dataset. That is how we do it. And then next, we are going to compare the CNN performance for the initial architecture. And after that, we are going to compare with the initial architecture with that of the another assignment 4. And we are going to redesign the convolution neural network and then again find out the accuracy and compare with the initial architecture. And part 7 includes project report. And the final part is about presentation, which I am doing currently, and also uploading these YouTube links. All right, now let's go one by one. So the data sets I have used in the first one is again Intel image classification data set. So that is used for the part two of the final project. It has 25,000 images classified into 6 classes. It has buildings, forests, glaciers, mountains, sea, streets. So these are the different categories of images that are present in the uh, dataset, Intel image classification dataset. So basically, it can be used for image classification or transfer learning experiments, feature extraction, and image processing research. So if I would like to show you a sample of a screenshot of the sample of this image classification dataset. You can see the first image here. It contains images of different, forests. So likewise, we have images of forest, glaciers, mountains, remaining things. Basically into 6 classes. And the next data set we have used in the final project is the CIFAR data set. So this is a primary data set used for training purpose, and it contains 60,000 color images and has 10 classes like automobiles, airplanes, and some other classes. So it is also divided into 5 training sub-data sets and 1 test sub-data set. So I can say that it is more complex because of its size, color, and the different classes. And this is used for part 3 of the final project. Again, the second image here in this um, basically shows the a Python code of the CIFAR data set. I know that it is blurred, but that's how the image is. Now, I would like to also show the document, what document report before going further. Uh, so this is a final document. Now, in the final document, you can also see that I have included the Intel image classification dataset that comes under part 2. And this is basically taken from the Kaggle website. You can see the URL link here and the description part, dataset, and these are the different uh, categories we have in the dataset. It has 14,000 images, 3,000 testing set, and then prediction set also. And it can be used for various purposes. So this is image again, and part 3 that is how to obtain the CIFAR dataset. Now the reason why I am showing the board document, this is actually the report because it would be too much to include everything in the slides. So for ease, I have included uh, I have also included this Word document in the recording. So basically, you can see that from here, how if I go to the modules, Professor has included CIFAR 10 data set under this module. So I have downloaded it. It has redirected to a Google Drive folder, and from there I have downloaded it. So and the next thing is that I have to upload it into GCP. Here you can see the screenshot of GCP. Um, and using the SSH option, I have actually uploaded it. So if I click the SSH option, it can basically show a pop-up in new window and show something like this. Using the Linux commands, I have just shown here what are the different files or folders present here. You can see that it has also folder JP, NTBK, that's one folder, and Jupyter another folder. And you can see two data sets. So and then in the JP NTBK, that is Jupyter Notebook short form, I have created a folder which is CIFAR 10 data folder. And in that folder, I want to move all the files or the all the data set which has uh, which is there in the canvas. So here you can see that this image shows the processing of the data sets. It has data batch 1, batch 3, batch 5, and then metadata. And then finally, once you can see that, I have moved, like I have copied from the uh, home directory to the CIFAR 10 data directory, and it has all the data sets. So this again, I have opened the Jupyter notebook, and from here also you can see that it has all the data sets. So let me quickly walk through the actual GCP. Again, it's the same thing. You can see this is the Google Cloud, and this is my this is my account. I have created ADTA550.teja@gmail.com Google account especially for this course, and I use the free GCP credits for this one. You can see that if I go to uh, here and then Compute Engine and click on virtual machines, you can see the different virtual machines I have initiated. I have actually initiated only one as of now because uh, this is the only one required for the final project and other assignments. Um, the name of the instance is deep learning. The zone you can see here, this is a zone. This is the SSH option. If I click here and open in browser window, it will be opening a new window. And then this is the name of the project. So basically, before creating the instance, we have to create the project. You can see there are three projects. Uh, it is in the first project I have created the that is ADTA 5550 hyphen project 01. It is in this project I have created my instance, and using this instance, I am running the Jupyter notebook. So let me quickly demonstrate that one too. So if I click on SSH, you can see that transferring SSH keys to the VM. And then if I click on authorize, it will take a few seconds to do that. So This is how it will be now. Now let me quickly type a simple command. So it shows different um, files present in the home directory. And if I want to change to APA slash, uh, let's at first let's change to this one, and then I would like to see the documents. In this one, you can see there is CPAR and AIS data. So these three supposed to be changed. CPAR 10 data. And if you, so by executing this code, you can see that these are different files present here. And so that is how it runs. So this is basically a virtual machine. And let me show another one for you. So also I have initiated the Jupyter notebook using this command Jupyter notebook by giving the port 888. And once I initiate this, uh, you can copy, basically we can copy the token given here. And if you use a command, Google Cloud, Compute SSH, ADTA, that is my username at this is my instance name and then project name and then the zone and then this command, localhost command. So basically I can host the Jupyter notebook in my uh, browser. So let me go through this one. So these are it looks. If I initiate, again, you can see localhost here, the Jupyter notebook. You can see that there are two Jupyter files that are running. That is final project part 4 and final project part 6. So this is all this comes under this part, which is part 3, that is obtained CPAR10 dataset. So now, till now, we have seen actual GCP and the virtual machine, and then what are the different files present in it, and also the Jupyter notebook. Now let's go to the another part. So coming to the model architecture, so basically what we are doing using the data set that we have, that is IFA data set, we have given at first, we have tried to convolutional layers by using 5 into 5 filters. And we have used the ReLU activation function and then maximum pooling and 3 fully connected layers. So when it comes to training, in total, we have given 5,000 steps and batch size equal to 100. So it will be training 100 at a time, and it has total of 5,000 steps. Now, this could also vary, like we can vary this too. In my previous assignment, I have used 3,000 and also 5,000 too. So here we have chosen to do it in 5,000. And so what we have observed is that after training, we have reached an accuracy of 99%, 9.99%, which is very low. Literally, it's a good performance. So this actually the part 4, that is building, training and testing CNN on CIFAR 10 dataset of the final project, where I have implemented a Python code using TensorFlow. I will also walk you through that code. So here you can see the architecture basically. Um, at first, we'll be having convolution layer and then maximum pooling, and then convolution layer 2, again maximum pooling. After that, we'll be having fully connected layer. So that is how the output will be. Okay. So before going for the performance comparison, let's let's go through the IP by NB file code.